everybody, and welcome to the Yes and Anywhere screen share visual art lesson. My name is Jenny, and I am so glad you're a part of our crew because this week we are in space and we are getting on our rocket and we are trying to leave the Earth right now. And so what I thought we could do is chart our progress as we try to leave Earth's gravitational pull. Yeah? Now I just watched Lindsay's video and she did a great job explaining how gravitational pull works. And she also had an expert. I can't remember his name right now, but he was amazing. He knew so much. You should go check it out. So as our rocket is trying to leave Earth, it's fighting really hard to get off the ground, then to get through the atmosphere, and then to break away from the gravity. And the gravity is what's holding us down right now. It's making sure we're not floating all over, right? So it's very, very strong. The gravity is very strong when we're really close to Earth. And then as we move a little further away, like where the moon is, it's a little bit less. And that's why astronauts can kind of float around. They hop a little more. They aren't as held in one place, yeah? And then as we go past the moon, we get even more floaty. There's even less gravity. And then we go even further, and there's zero gravity. And so I thought it would be a very good idea for us to chart our progress so we know where we are in this vast expanse, right? Exactly. So for this activity, you're going to need a piece of paper, something to draw with, tape, scissors, and some string. Now you may also need some helping hands when it gets to the tape and string part, okay? Materials needed for gravitational charting. 1 piece of paper, something to draw with, tape, scissors, and a piece of string. You may need helping hands along the way. Alrighty, y'all. Once you have your materials, let's take your paper out, and you can start by drawing an Earth in the top left corner of your paper. I made mine a little fancy-dancy, but you can also just draw a little semicircle and call it Earth. Next, what you're gonna do, once you've drawn your Earth in the top left corner, so you're going to tape down your paper in the 4 corners, okay? Alright, and once you are all taped down nice and flat, not going anywhere, you can take your piece of string, and what you're going to do is measure it out so that it's the length of your paper, and then with a little bit of extra on the end so that you can tie one end to whatever you are using to draw with. Okay, so it might be helpful to tie it to whatever you're going to be using to draw, measure the length of your paper, and then you can snip the end. All right? Now what you're gonna do is take this end and you're going to hold it at the very top left corner where Earth is. Now because we're actually starting on Earth, we're gonna place our whatever we're drawing with on Earth, and then we're gonna work our way out. Here's the catch though. This string is acting as the gravitational pull towards Earth. So this is what the orbit would look like. So when we're really close to Earth, the gravitational pull is really strong, and so we're right there. So what I'm gonna do is shorten up my string, pull it real tight, real close to Earth. I'm gonna uncap my marker. You don't need to tape down your string. We're gonna loosen it up and get it all the way out to the stretch of our paper, okay? So don't tape down your string. Right now we're gonna make it really short so that we're right at Earth, and it's so close to Earth, and my rocket is trying so hard to leave Earth, so I'm going to start by just drawing my rocket. should be kind of difficult to draw because it's so tight. The gravitational pull is so strong towards Earth that it's struggle. So once you've drawn your rocket, now our rocket is going to try to pull more. It's going to try to further from Earth. Here we go. Let your string out just a little bit. And it's going to get to about where the moon is. So how about we go ahead and draw the moon, where we have like a little more room, but still pretty tight. And it's gonna look kind of funny because we're stuck in orbit. So we can only go out so far before we can only move side to side, right? So this is my moon. It's got its big craters. Maybe it's even got the little flag on there. So this string, like I said, is acting as the gravitational pull in the orbit. So you don't need to draw this, but I'm gonna draw just to show you guys. So the way the string is pulling and where my marker is the moon's orbit. Now you don't have to draw the moon's orbit, I just like drawing it because it's kind of cool. Okay, now our rocket is gonna go past the Earth's atmosphere, past the moon, and it's gonna try a little further, so let the string out a little bit more. And now you're in the asteroid belt. So let's draw some asteroids out here. And I think I'm also gonna draw maybe a couple stars. Real small ones. We're in the stars now. And then I'm gonna pull even more. I'm getting further from Earth so I get even more room to draw. So now we're gonna go a little further. And now I'm gonna draw a comet. So we're all the way out there. I can still kind of feel Earth's pull. I'm gonna draw some bigger stars. In yours, maybe you're seeing a constellation where you are. Maybe you're seeing a shooting star. I'm gonna draw a shooting star. The whole time you should be holding down in your top left corner your string. I know it's a challenge. This is our rocket science. And then I'm gonna pull even more. So I'm almost to the end of my string, but not just yet. And now I have even more room. Now out here, I'm gonna draw a flying saucer, a UFO. My rocket is gonna meet a UFO. I know there's aliens out there. I'm sure Philadelphia has already seen aliens. We're so far from Earth now, I'm actually seeing another planet. It has rings. It has some crazy rings. What are you seeing? More stars, maybe? Bigger stars? Smaller stars? And then I'm gonna pull all the way to the end. And I'm all the way out here. You almost can't see me. And all the way out here. You know what? I don't know what's out this far away from Earth. I mean, we got the moon, we got the asteroids, we got comets and stars and shooting stars and aliens and other planets. What's all the way out here? Maybe it's another galaxy? I'm gonna draw a galaxy. Whole nother solar system, maybe? Maybe there's another sun. I'm gonna say there's another sun. And then if we pull a little more, oh, we're free. We're free from our gravitational pull towards Earth, and now we're free floating. We're free floating. Now we can do anything. We can draw whatever we want. There's a black hole over here. It's taking everything in. And there's a wormhole over here. So now we know when we get to the moon, we're almost out of Earth's gravitational pull. Then we have to get out of the moon's orbit, and that's when we get to the asteroid belt, and we're seeing some stars, maybe a shooting star once we get further away. There's still a bit of a pull with the moon and the Earth. And then we get a little further away, and now we're pretty loosey-goosey out here, and that's where the aliens are roaming. That's where, when we really curve around, we fall into another orbit. We find black holes and comets, maybe another galaxy. What did you discover as you made it further and further from Earth? Sparkle you, sparkle me, sparkle us. We have already discovered so much, already learned so much, and it is just the first day. I can't wait to see what else we discover this week. Thank you so much for joining me. I will see you next time. If you would like to post a picture, I would love to see it. For now, goodbye.